understanding, if you have a solid understanding of what this area process is talking about, then you recognize immediately that this is not a good-looking problem based on the way we've been doing things. Because let's say, for example, I found the integral, so I'll take a stab at it. People who struggle in this course, they struggle because they're like, all right, I'm just going to write an integral and hope it's right. Right? That's obviously not the way to go. So here's an example of what you don't want to do, but I'll explain why you don't want to do it this way. You think you're going from 0 to 2, because that's what we've been doing for all the other problems. And we have this function. It's one function. Great. All right, so let's think about what that's going to give us. The integral is going to give us the area bounded between the function and the x-axis. All right. Now, this may actually help us to sort of go about getting the right answer, but what it's giving us is this guy here and this guy out here, bounded between the function and the x-axis. So a little bit of what we want, a little bit of what we don't want, and then a whole lot of stuff is just completely excluded for some reason. However, you can look at this and say, well, that's going to help because I can figure out this with geometry. I can figure out that if I broke this up at 1. I could do some subtraction, come up with that shaded region. That could work. All right, so okay, no go there. Maybe you think, all right, well, he did something with absolute value, so that's probably the answer. Still no dice, because all that's going to do is take this negative region here and make it positive. So it'll give us that guy and this guy. Still a whole lot of stuff that we don't want and a whole lot of stuff that we need that's excluded. Oh, wrong thing. Negative. Oh, yeah, that's what I'm getting at. Thunder scope. That's good. That means no spikes. So let me get this out of here. Let me do a little bit of this. Paste it in, edit, paste. Whoa, too big. Make it tiny. That's fast. Alright, so I go whoop. And then oh, well, get there eventually. Flip, left, right. Yeah. I just got to do it often enough without thinking, and it tends to work out. So what this would be telling us, if you look at it from this perspective, say, well, it would be perfect if I went this route because then the entire region is bounded between the curve and the quote-unquote x-axis. The problem is it's not really the x-axis, but if I change my perspective and look at this from the perspective of y, that's gonna help me get my area with one single calculation. All right, so this guy wasn't going to work. It could have. I mean, there was a workaround. You could have got there eventually, but it wasn't feeling right. We want this. So we're going to go from -1 to 3. Our perspective is going to be with respect to the y variable. The only issue is I now need an expression that's in terms of y. All right, so my original expression, y equals x squared minus 1. I'm a little algebra away from getting what I need. All right, add the 1. X squared is equal to y plus 1. And then root it. X equals root of y plus 1. plus or minus, yeah, but there's no part of this graph that's below the x-axis. So I don't actually need the minus. So, you know, you can kind of streamline the process. But now I know what my integral, or my integrand, should be, the root of y plus 1. This integral will give me exactly what I need. And this one example, I mean, we were kind of building towards this. View, zoom, page width. This one example is a good indicator problem. If you can handle something like this, then you're in great shape, because a lot of the issues that students have with volumes of revolution only occur because they have difficulty changing their perspective from x to y, y to x, inverses, and things like that. If it wasn't inversible, then you would have trouble. You would have trouble. However, you can still come up with a general way of representing it instead of saying, you know, the integral of f of x dx. You could say integral of f of y dy, and then make a note. I can't come up with f of y, but if I could, I put it in and I get the answer. You know, so it would be something along those lines. All right, so I'm going to put stars on everything else on this page. Meh, 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 and meh. And what I'll say is that if you have really